So welcome to the another video of data structures using Java. We are going to start with the sorting algorithms. We will be covering what do you mean by sorting, and we will see the types of sorting algorithms, and finally we will implement the bubble sort in this video. So let's check out what exactly the sorting means. So sorting is nothing but the rearranging the elements. If you see, observe carefully, I have written in the definition, the sorting algorithms are nothing but it is basically used to rearrange the elements present in my array. Now you can rearrange this element either in ascending order or you can rearrange this in descending order, right? It's upon you in which order you want to rearrange your elements. Now in order to rearrange these elements either in ascending order or descending order, there are 5 types of algorithms basically we can use it. The one is bubble sort, insertion sort, selection sort, merge sort and quick sort. We are going to see each and every single sorting algorithms in detail, but in this video we will be specifically focusing on bubble sort. So let's start with the bubble sort, how exactly the bubble sort works and what will be its implementation. So let's check how exactly the bubble sort mainly works. So what bubble sort basically do is it simply compares the two adjacent elements, and if those two adjacent elements are placed in the incorrect way, they simply get swapped. For example, let's suppose I want to arrange this element in increasing order. Okay, now see, 4 and 1, these are the adjacent elements. Now in order to have the elements in increasing order, my 1 should come before 4, which means these two adjacent elements are not placed in their correct format. Simply I am going to swap it. So how will my array will look like? So my array will simply look like 1, 4, 2, 5 and 3. And again I will compare these two adjacent elements, and I came to know that these two are not correctly placed because my 4 is greater than 2 and I should have 2 before my 4. So again I am going to simply swap it. So in this way each and every single adjacent elements are compared in order to rearrange the elements in increasing order. So this is what the short idea I have given you on the bubble sort. So now let's check out the full implementation, how exactly the internal working of bubble sort take place. So to perform the bubble sort, there are total n-1 number of operation takes place. Now the question comes, hey Pramod, there are total n elements, but why should we perform exactly n-1 number of passes? The reason behind this is, let's suppose there are total 3 elements. Let's suppose there are total 4 elements present in my array. Now what exactly happen is, in first pass the largest element will get placed in its correct position. Okay, now in second pass the second largest will be placed in its correct position, and in third pass the third largest will get placed in its correct position. Now see, there are total 4 elements, out of which the 3 elements are already in their correct position. So there is only 1 element left with, and if these 3 elements are already in their correct position, which means the remaining element will automatically be placed in its correct position, right? That is the reason why we need exactly n-1 number of passes. And now as we discussed above, that the two adjacent elements are compared, and if they are not correctly placed, we simply swap it. So this is how exactly the bubble sort work. Now let's check the each and every single dry run of passes. Now let me know that here the total size of my array is 5. Then how many number of passes will take place? The total passes will take place n-1, which is nothing but 4. So we need to perform the 4 passes in order to arrange this element in increasing order. So let's check out. So let's get the first pass. Now what we said that the elements are 4, 1, 2, 5 and 3. Now what will happen? The two adjacent elements will be compared. Are these placed in their correct position? No. Then simply swap it. So I got 1, 4, 2, 5 and 3. Now again these two adjacent elements will be compared. Are they placed in the correct position? No. Then simply swap it. 1, 2, 4, 5 and 3. Now check this. Are these placed in the correct position? Yes. So we don't need to swap them. So it will remain as it is, 1, 2, 4, 5 and 3. Now check these two elements. Are they placed in the correct position? No, because 3 should come before 5. So it should be 1, 2, 4, 3 and 5. So this is my first pass, right? This is my first pass. And if you observe carefully that the first largest element came at its correct position. And this is what we discussed over here, right? In the first pass, there will be exactly one element which will be present at its correct position, that is the largest element. Now let's start with the second pass. Now what will happen? I will get this array as it is, that is 1, 2, 4, 3 and 5. It will compare these two elements. Are they placed in the correct position? Yes. So no swapping will take place. Now it will compare these two elements. Are they placed in the correct position? No. So simply I am going to swap it. So 4 and 5. Now we'll check, is this placed in the correct position? Yes. So I don't need to swap it. Now see, I am completely done with my second pass, and you can observe carefully that two elements came exactly into their correct position. So in second pass we got two elements in its correct position. In first pass one element came at its correct position. Now still I need to look after 2 more elements, right? So again I am going to perform 2 more passes, that is third pass. Now what is my element? 1, 2, 3, 4 and 5. Now see, now you may be saying that, Pramod, the array is already sorted, then why we need to perform the third pass? No, because what happened is we have performed exactly 2 passes, which means the 2 elements are its correct position, but still we don't know about the remaining 3 elements. At least we should bring another 2 more elements into its correct position, so that we can sure shot say that the remaining element is exactly in its correct position. So let's perform the third pass. I will compare these 2 elements, they are correctly placed, so our array will be as it is. Again I will compare these 2, they are correctly placed, so my array will be as it is. And now I will compare these 2, my array will be as it is, 1, 2, 3, 4 and 5. Now there are total 3 passes took place, and 3 elements are exactly into its correct position. Now the remaining 2 elements, so I need to bring at least 1 element into its correct position. So let's perform the final pass, that is fourth pass, 1, 2, 3, 4 and 5. We will compare these two elements, they are already correctly placed. So 1, 2, 3, 4 and 5. Then I will compare these two elements, they are already correctly placed, 1, 2, 3, 4 and 5, and these two elements already correctly placed, and I will finally compare last two elements and they are already correctly placed. Now see, there are total 5 elements, but I have performed 4 passes, and after 4 passes the first 4 elements are exactly placed into this correct position. So the remaining element will automatically present into its correct position. That is the reason why I need n minus 1 number of operations. So this is how exactly bubble sort works. Now let's identify some patterns in it, right? What we did is, for the first pass, when I equals to 0, when I equals to 1, I equals to 3, I equals to 4, right? Because there are total 5 elements, I am going from 0 to 4. 0 to 4. What is happening? When I equals to 0, total number of comparisons are taking place n minus 1, and for this n minus 2, n minus 3, n minus 4 and n minus 5. These number of operations are taking place, which means if I keep the size of n as 5, total operations it would become, for I equals to 0, it would be 4, 3, 2, 1 and 0. 0 number of comparisons will take place. Now what exactly you come from this pattern? When I equals to 0, my n is n minus 1. When I equals to 1, it's n minus 2. When I equals to 2, it is n minus 3. So can you identify some pattern there? For any value of I, that is from 0 to n minus 1, the value of j ranges from n minus I minus 1, right? Let's see. The value of I is 0 and n is 5. So 5 minus 0 minus 1, it would be 4, and which is indeed we got as 4. When I equals to 1, so 5 minus 1 minus 1, which is nothing but 3, and which we got exactly 3. So the outer loop will run for n minus 1 time, that is outer loop, which is nothing but passes, and the inner loop, which is basically used for comparisons, it will run for n minus I minus 1 times, n minus I minus 1 times. So how exactly the pseudocode of this algorithm will look like? So simply, this is for outer loop to get the passes, and what we discussed, how many passes we require? N minus 1 number of passes. So simply run a loop from I equals to 0, I is less than n minus 1 and I plus plus, and then inner loop will go from j equals to 0, j is less than n minus I minus 1 and j plus plus. And what we need to do is, what we did is, if two elements are not correctly placed, see over here, if these two elements are not correctly placed in their position, we simply swap it. So we are comparing the current position with next element. So if a of j is greater than a of j plus 1, what we basically do is, we simply swap a of j with a of j plus 1. So this is how exactly the bubble sort mainly works. Now if you try to get the time complexity, what will be the total time complexity of this algorithm? If you see, my outer loop is running for n time, right, from 0 to n minus 1, which is nothing but the n times. Therefore my outer loop will take big of n time, and my inner loop is going from 0 to n minus I minus 1. But if you see carefully, when my value of I is 0, it is going nearly n minus 1 time, which means approximately n times, which means the inner loop is also going approximately n times. Therefore the overall time complexity would be big of n into n. So this would be my overall time complexity of bubble sort. So I hope so you understood the working of bubble sort and the implementation of bubble sort. Now let's move on to IDE and try to implement this code. So what I did is, I simply took one array and I have inserted these elements, and the total size of array is 7. So let's go with outer loop, which is nothing but passes, right? Total number of passes for this. So I know that it will go from I equal to 0, I is less than size minus 1, right? I plus plus. And inner loop, how many times inner loop will go? That is I equal to j equals to 0, j is less than size minus I minus 1, and it will do j plus plus. And what we need to do is, if AR of j is greater than AR of j plus 1, then we simply need to swap it. So how we can swap it? We can have the temporary variable, let's suppose temp, and then I will put a of j, and in a of j I will simply put a of j plus 1, and in AR of j plus 1 I will simply put the value of temp. And finally when I come out of this loop, I can simply print my array, just to check whether my array is completely sorted or not. So if I do so, AR of I, yes. So this is a simple code what we discussed on the iPad. So next try to run. Yes, if you see carefully that my array is completely sorted as 1, 2, 5, 10, 22, 33 and 90. So this was a short video on bubble sort. I hope so you really like the way I am teaching you. Just in case if you are new to the channel, do subscribe the channel for more such informative videos.